Well, good afternoon, everyone. Welcome to the Energy Conservatory's presentation on blower door basics. This will be an hour-long discussion on tried and true techniques for using this is a very effective diagnostic tool. My name is Frank Spivak. I am the Marketing and Sales Manager for the Energy Conservatory, and we'll continue on with our presentation. So this will be recorded for viewing and downloading later. If you do not have sound, please check the volume and mute settings on your computer as well as any of your speaker connections. And if all else fails, you can also call in to hear the presentation while it's being given. If you do have a question, we ask you that you use the chat section in the right of your screen, and we will then be able to try and answer those questions as they come along and answer them for you. We'll also have a few minutes at the end of the presentation to do a short question and answer period. Our agenda today is to provide an overview of house leakage basics and blower door equipment. We also will talk about how to set up the blower door for consistent and accurate test results. And we'll explore how to do a test and how to use a digital gauge to perform that test. First, a little bit of an information on house leakage. I know that this is a graphic that many people might have seen. This was developed through the Department of Energy, but it's a terrific way of showing people where some of those leakage sites may actually be taking place. So we have areas that leak in a variety of locations. So for example, we have, you see the ceiling connected to the attic, and we have the attic hatch, leaking on the sides, even though the attic hatch itself might be a good seal. We have leaks around the chimney, through recessed lights into soffits, around bathroom fans, and recessed light fixtures. We also see them in the lower portions of the house, in faucet connections or air conditioning connections to the outside, where you have the line sets connecting the compressor back into the air conditioning system. Electrical outlets that are on the outside of the house, which may also be in a cavity that has an interior electrical outlet, which creates a perfect form of airflow from inside to out and from outside to in. Some hidden details that are also useful to think about is anytime that you see a structure, a house, a big building, or anything like that, anytime that a pure rectangle or square is interrupted by something else, those are locations to see where there would be a leak. So for example, cantilevered portion in a bay window is also a very common location for leaks, which will then travel throughout the structure, or at least through the joist cavity that's present in the floor. Anytime that you have a new roof line attached to a sidewall, offset flooring such as in a split level house, each one of those are potential locations to look at. Is there a good seal? Is there any thermal bridging? Is there airflow moving across it? Just to give you an idea of some pictures of hidden details, you can see on the left-hand side, someone added a water line to the kitchen area of the house, and so the plumber did a marvelous job of creating a hole to put that line set through, but unfortunately never sealed it. So now we have a location where the crawl space is leaking directly into the underside of the kitchen cabinet. The image on the right shows where there is a filter panel for the house, which acts as a return. And for some reason, the contractor decided to stuff that area between the drywall and the body of the house, or this chase area, with insulation. And insulation is not an air barrier, so you can see that when we've started to pressurize the house, you can see that the air movement through the smoke bottle is now moving through the cavity of the house. Duct leakage also is an important aspect. For example, the image on the left-hand side, you can see how it was never really completed with the connections from one transition to the next in this duct system. And the hole is large enough where this particular person was able to stick their finger through. You can also notice that on the left-hand side of that image, the insulation, where it's dark, you can see that then the insulation is now acting as filter media instead of true insulation. The drawing on the right-hand side also gives you an idea that if we don't seal all the wall cavities, and they may be connected to various systems like an air handler or the return airflow, that is going to cause a leak that affects energy efficiency, comfort of the house, and how the occupants are enjoying their facility. So when we look at a blower door test, what is it supposed to do? Primarily, it's to document the relative air tightness of a house. Is the house actually leaky? Is it tight? Is it somewhere in between? What is it that we're looking at in the house to figure out, is this something that needs to get fixed or not? It also is used to help find those air leaks by inducing air to move through the house, which can then also be found through uses of chemical smoke, infrared camera, even feeling around locations where you think there might be airflow and just feeling with your hand. And then a more advanced method would be for using zonal pressure diagnostics to help find those locations and which ones are the primary ones to start working. We also want to determine the effectiveness of air sealing activities. What was the number before and what was the number after? Did we actually fix what we thought we were supposed to fix? It's also used to help investigate for duct leakage problems and also help to estimate the need for mechanical ventilation. We try and seal up these houses as tight as we possibly can, but then we also need to figure out, how do we bring fresh air into the house? Through a blower door test and determining the air tightness of the structure, that will help us in determining mechanical ventilation requirements for makeup air. So what is a blower door test? The blower door fan is used to blow air into or out of the house, which would be a depressurization or a pressurization test. We want to put as much pressure into the house to bring it to a set value, and that set value has become 50 pascals. The amount of force that 50 pascals creates on a house is about the same as a 20-mile-an-hour wind. So once we've determined that we've reached 50 pascals, we want to measure how much airflow is moving through the fan. So the flow through the fan is needed to create that pressure, and then we measure how much air is needed to maintain that 50 pascals. So CFM 50 is really a measure of the total equivalent hole size. So if we added up all of the different holes in the house, big, small, medium, CFM 50 is a measure of how big that hole really is. We also use a few other ways of determining how airtight the house is. One of them is using the air changes per hour at 50. Now, many of you may have started to learn about Energy Star version 3 and some of the other protocols that are being required through the International Energy Conservation Code of 2012. And what they're looking for is an air changes per hour value. And the 2012 version, in some locations they're looking at 3 air changes per hour, and some states are making modifications to start getting people to move into it. But the air changes per hour at 50 Pascal is used to figure out how big this leakage is when we compare house to house, even though they're different sizes. So the general guideline that we've come to use is that if the air changes per hour at 50 is less than 1.5, that this is a very, very tight house and certainly will require mechanical ventilation. It's also a house where any use of atmospherically vented appliances is going to be a real problem. We then go to 1.5 to 3. This is a tight house and also requires mechanical ventilation. You may still have one atmospherically vented appliance, but generally we don't want to have it there. 3 to 6 is typically pretty good construction, and depending on the size of the house and other activities such as how many bedrooms there are, how many occupants and things like that, it may indicate that you will require mechanical ventilation. Then we start getting into 6 to 10 air changes per hour, and then certainly 10 and above. These are very leaky houses and will need activities around air sealing to really bring this house back into a more comfortable environment and something that is going to be more energy efficient. And the simple formula for air changes per hour at 50 is taking the CFM 50 from our blower door value, multiplying that by 60, so that now gives us cubic feet per hour at 50, and divide by the house volume. Blower door equipment. This is certainly the offering that we have from the Energy Conservatory, but certainly any manufacturer that creates or that sells blower door equipment is going to have very similar equipment. We have a blower door fan, a door frame, some form of gauge of reading the value, and a case to hold all of the various accessories. For our particular system, we have a series of rings which reduce the airflow based on how much air is needed to maintain that 50 pascals. So you want to look for the calibrated fan, number of flow rings, accessory case, gauges, and tubing and manual. Now, airflow is actually determined by measuring the flow sensor pressure. So the drawing on the right-hand side is just kind of a cross-sectional value or image of a blower door fan. On the very far right, you'll see the flow sensor. This is mounted on the back of the blower door fan motor. And as air is drawn across that from the fan blades, then that pressure is measured by the digital gauge. We know how big the blower door fan is, the inside diameter, and so we can take a standard formula of taking the pressure, converting that into velocity, and multiplying it by the opening. That would then give us the total amount of airflow moving through that fan. Now, all of our fans that we currently make do have just flow in one direction. You cannot reverse the fan motor. And the reason for that is that you can only measure airflow in one direction. So we're going to be measuring the flow from the flow sensor through the fan blades. If the motor has been reversed, the value that shows up is going to be incorrect. So here is a drawing or a picture of our blower door fan with the flow rings. So we have ring A is attached to the fan, ring B is next to it, and the no-flow plate. The no-flow plate is used when we're determining baseline values, and we want to find out what is the standard pressure of the house sitting naturally. So the flow rings are used to determine how much airflow. So we can go down to ring B, and get the house pressure values or get the flow values down all the way to 300 CFM. Now there are also rings C, D, and E, but given the housing stock for the United States, ring B is probably the most common and would not really be necessary unless you're working on something like possibly a passive house or a net zero energy house. When we're installing the blower door, we want to install it on an exterior door that has a large enough opening. We want to avoid installing the fan where there are stairways. So for example, in Minnesota, there is a housing style called a split entry, where you walk into the house and have a very small foyer followed by a stairwell that goes up and a stairwell that goes down. This is not an ideal location because you can provide obstructions to the flow, and we want to avoid that as much as possible. It can go on a porch, a door that leads to a porch, as long as the porch is open to the outside. And just trying to place it in a location where we can also place tubing far enough away from the fan so that the tubing isn't affected by the airflow passing over it. We also want to find a location where we're going to be a little bit away from the wind. So we want to place, generally we want to place that tubing at the in the bottom corner of the house, someplace where it's obstructed. Sometimes people will place the hose inside of a bottle or a can just to try and make sure that there's no air moving across the opening of the fan of the tubing. So the blower door frame is kind of an integral part of putting everything in place. So one of the things we'll show you a very quick video on how this gets all put together. The frame is assembled. We have the center crossbar for the fan. It's sized for the height and width of the door. We place the nylon panel over it, and to ensure that it stays in place, we flip the cam levers over to make sure that they're nice and tight. Once the panel is in, we then install the fan, and the fan is held up on the crossbar. We want to make sure, again, that the nylon panel is nice and tight, and that we want to make sure that we're installing the flow rings on the right side of the house. So if we're doing a depressurization test, that means we are going to suck air out of the house, then we want the fan with the flow rings on the inside of the house, just as we have in this picture. If we're going to do a pressurization test, we will have the flow rings on the outside, and what you'll see on the inside of the house is the exit guard of the fan. It'll be pretty noticeable too, because when you turn the fan on, the air will be blowing at you while you're inside the house. Some people ask, what's the difference between doing a pressurization or a depressurization? The simple answer is there really isn't much of a difference. You will get a very similar answer. When you are depressurizing the house, many of the natural gravity dampers of the house, such as bathroom vents and the like, and range hoods, will help suck those dampers closed. When you're pressurizing, you will actually open those all up. So your number might be a little bit smaller when you're depressurizing and a little bit larger when you're pressurizing. If you really wanted to try and be very accurate, you could do both tests and take the average of those. But your numbers are going to be very close. Kind of the heart of actually taking measurements is using a suitable gauge. So we manufacture the DG700 pressure and flow gauge, which has a 2-channel simultaneously displayed gauge. We have a number of buttons on there to provide for proper readings and also reading formats. So if we're going to do a blower door test, we would want to use pressure and flow. We could also use some of the customized settings of with pressure flow at 50. We'll talk about that in just a moment. This is a typical connection, the way someone would see it in the house. You're doing a depressurization test, and on channel B, on the input, we're putting that to the fan, and channel A reference we're putting to the outside. Now, some people may put the reference tap to the outside on the input. You can do that, but just understand that you want to make sure you understand which way the pressure sign will be doing. When you see the display, if you were to place the input hose or the reference tap to the outside and put that on the input, you'll see a number that's negative, and you just need to understand what the sign of that value is and where are we making reference values. And here's a typical pressurization test setup. We've added this additional hose tap to the reference port of channel B, and then this will help. This is assuming that the gauge is on the inside of the house, and so we will have a better idea of how this works. When we add the reference to the outside, it's because now the flow sensor is on the outside of the house. As we mentioned, that there is a simultaneous display of house pressure and fan flow. We have on the left-hand side, when you see device, we have BD3. That's telling us that it's a blower door model 3. We have our pressure value that's being displayed. At the bottom is pressure and flow. On the right-hand side, you can see that in under configuration, we have ring A1, and that our value is being read in cubic feet per minute, and that our time average is 1, meaning that you will see a new value every 1 second. The time average can be changed to show it in 5-second values or 10-second or a long-term. When it's a really windy day, you would want to put it on a time average of long-term. So here's our specialized test modes. Again, you'll see that we have the devices blower door 3 and our pressure value. But now in the mode area, you'll see that we have pressure flow at 50, which means that the gauge will automatically adjust the value on the right-hand side as if you could reach, as if the house were already at 50. So for example, in a very leaky house, and you might only be able to get to 35 pascals, the value on the right-hand side when you're in the CFM at 50 mode will be displayed as if you had enough fans to put in enough airflow, what would that value be? And so many times it's referred to as the can't reach 50 factor, and that's all built into the gauge. Some additional test features with the DG700 is a baseline feature. Now the baseline is we actually want to take a test that adds 50 pascals of pressure. Now the house, when it's sitting there, will have some sort of natural pressure value. So for a house that might be in a city block where there's a number of houses all nearby, you won't have much of a wind effect, but if it's a taller structure, there might be some natural stack effect because of the leakage of the house. And so we want to find out what that is. So the baseline feature makes an adjustment to say, okay, if my house is at 4 pascals negative, I still need to add 50 pascals. So the normal math would be if my house is at a -4 and I need to ensure that I'm getting a 50 pascal difference, if I didn't do the baseline adjustment, I need to bring the value of the house down to -54. Because we want that 50 pascal value. By using the baseline feature, it helps eliminate some of that, determining whether I have a negative number and how to put all that together. Some other test features regarding the baseline is not being used as a blower door test, but as a way to determine what the pressure is for a combustion safety test or a worst case depressurization test. So what we would generally do is we push the baseline and then start. We wait a few seconds for the baseline to be measured, and you'll see that in the upper right hand corner we've turned our fan on, and now our fan is off, and the baseline of the house after 25 seconds is a -2.6. We press the enter button and the DG700 will show an adjusted value, ADJ, and then we start measuring and see the true pressure change when we start turning fans on. So after we've pressed enter, the gauge goes back to 0. We start to turn on a fan, and that happens to have a value of 7.8, but because we've already done the adjustment, the real difference is 5.2. So you can see down in the lower right hand corner we're showing that value of 5.2 because that's the difference of the house when we've adjusted for the baseline. If we didn't adjust for the baseline, we have our value of 7.8. We have to subtract 2.6. We still come up with 5.2. Some other features of the DG700 is being able to cruise without a computer. This helps in maintaining a constant house pressure. Many times it's used for air sealing investigation. We have the ability to cruise 75, 50, 25, or 0. Why have the 0 function? One of the things that people might want to find out is how much airflow is a dryer contributing to the house, because it's not a very easy measurement to make. So we set the gauge up to cruise 0, and when the dryer fan goes on, the fan will automatically adjust to 0, and when we do that, now we know how much airflow is needed to neutralize the pressure that's being caused by the dryer, and that gives us a CFM value. The Cruise 25 value is very useful for doing duct leakage to outside, and we'll talk a little bit about that later on. We want to maintain 25 pascals while we're doing a duct leakage test, and that is a very useful function. Now there are older gauges that the way to determine if your gauge has cruise capability is that you won't have any of the red writing on the buttons. Older gauges are able to be upgraded to cruise. In order to do cruise, you will also need to have a blower door controller, fan controller, that has this fan control port. And so you'll notice in the picture on the right-hand side, you'll see fan control and something that looks like a headphone jack. And that's our cruise feature. That's the ability to have the fan maintain a constant flow. The gauge is sending a signal to the controller that will automatically adjust the speed of the fan. Now, this has been standard equipment on our equipment since June of 2007. And certainly older fans can be upgraded to cruise with the fan speed controller because it's a simple purchase along with the fan control cable. When you're using the gauge, we also have the ability to document pressures of the house using a program that we call TECLog2. And this is a data logging program that will display and record both pressure channels. So when we, in our previous example of how to measure the worst case depressurization, in this graph you'll see that we can document which fans contributed to the depressurization of the house and which ones are contributing more, and what the total effect is when we add each fan onto the system when we're doing a depressurization. So TECLog2 is a very useful program. It's also very powerful because it's designed where we can take as many as 16 gauges and monitor those. So when someone might be advancing from just doing home investigations to big buildings, TECLog2 is a perfect way to document the flows and pressures of a large building with a number of fans and a number of pressure values. Starting in November of 2009, we added a USB cable connection to our gauge. So this picture on the right-hand side actually shows a serial connection, but we do have an additional USB connection. We point that out just because USB is it's kind of tough to find a computer nowadays that actually has a serial connection, but serial connection on the gauge is useful when we're doing big building testing and we have long runs of cable that we want to monitor. USB is good for about 15 or 16 feet, maybe 20 feet at the most. Automated testing with a DG700 using TECTITE does reduce operator errors, improves consistency between tests, provides better precision in windy weather, and also helps to store the test results and generate reports. Some of the things that we commonly see or hear about when someone's talking about problems with their blower door is the tubing connections to the gauge are wrong. So they might be either top to bottom or even channel to channel. Sometimes those aren't in the right places, sometimes they're reversed, sometimes they put both on one side, and those all contribute to reading values that don't make sense. Another important part is making sure that you have flow rings. So sometimes people will add the flow ring to the fan itself while it's in the doorway, but then forget to make the adjustment on the gauge to go from open to ring A, and now your number will be a little bit out of sync. Sometimes those readings are, those errors are because there's a failure to take the baseline reading in the house, and it's not, it affects how much airflow you need to bring into the house. And another is forgetting about you know, a window or a door that might be open, and just making sure that if you get numbers that don't make sense, do another walk around in the house and make sure that each one of those is closed. Now, a manual blower door test is pretty simple. We're going to set the gauge to pressure flow at 50 mode. This is the most useful because then you don't really have to get 50 right on the nose. We measure the baseline house pressure, cover that in the baseline feature. We uncover the fan, then increase the fan speed with the controller, and we adjust the controller to change the house pressure. We've talked about this. We just want to make sure that we're increasing by 50 pascals. So once we've done that on channel A and we see 50 pascals or close to it, we read the pressure on channel B for the CFM at 50. Now if channel B starts to show low while you're reading the CFM at 50, now you need to add ring A or ring B and make sure you change the configuration on the gauge. Now we're going to, by measuring and figuring out what this the airflow is, it will help us determine if air sealing is actually a cost-effective function. We want to use the blower door during the air sealing work because it helps identify, have we hit the big holes? Have we done enough to actually make a difference on this house? And then we're doing that test again when it's all done to verify for the homeowner that we have good results. Now, the only thing that's obtained from a blower door test is CFM 50. All other values are calculations. And if you want to do more calculations, then you really need to use the TECTITE software, either in the manual or the automated mode, but you should use the TECTITE software to come up with that. So you'll see that the results page of our TECTITE program, in the upper left-hand corner, you'll see airflow at 50, the approximate leakage values. In this case, was just the Lawrence Berkeley value for equivalent leakage area. This is a standard level of test. This was done with a ResNet 1-point test. You see the estimated infiltration value. These again are all calculations based on climate, where you're at, all those kinds of things. We have an estimated cost of air leakage, which may be helpful to you, but understand that these are extremely conservative numbers and may underreport what the effect of actually sealing the house might be. In the lower right, you'll see mechanical ventilation guideline, which is based on ASHRAE 62.2, 2010. Now, that particular standard has been written in code language so that it can be adopted by a number of local authorities. So you will see that many states and local authorities will implement the mechanical ventilation guideline. So you can see in this what the recommended whole building ventilation should be, what the base rate is, there's a supplemental rate, and then you get an infiltration credit for how leaky the house is. So we have the 62 plus the 38 minus 30 brings us back down to the 71 CFM value. Some of you might have used TECTITE. We have some new screens in TECTITE 4.0. For example, in the building information page now incorporates some of the other some of the screens that were in separate screens. And then we've also added the volume, floor area, or surface area, bedrooms on this one single page. And to help with this mechanical ventilation rate, you can see that we can determine whether we have a new house or an existing house. How much are the existing fans helping? So this is the kind of information that feeds back into the ASHRAE 62 formula. Do these bathrooms have operable windows? Does the kitchen have operable windows? And how much airflow do each of those fans provide to the house? And you'll see here that on this screen that we have the manual, the auto, and semi-auto. Semi-auto is that you manually adjust the fan speed, but allow the computer to collect all of the data from the DG700 and add that to the report. We also have here on the test standard, we have the CGSB, the standard one. We have a ResNet 1-point test, which is really a manual test, a ResNet multi-point test, which is similar to the CGSB test, but meets certain requirements for the ResNet standard, and then a ResNet repeated 1-point test. So our software does comply with the latest updates for the standard for ResNet. So if you're not familiar with it, please refer to Chapter 8. This became effective January 1st, 2012. And we know that some people haven't actually seen that or have completely understood it or implemented it. Part of that, then, we know is we will be holding a webinar specifically on ResNet testing, which will take place probably the second week of November, around the 7th or 8th of November. Going back to the estimated infiltration rates, those are just that. They are estimates, so use them carefully. And they can vary from day to day, depending on the wind, the temperature, and the like. Something that we've added is the iTech ResNet app for both the iPhone and the iPad. We don't have anything for the Android system yet, but we're working on that. What you'll see on the iTech ResNet app is a place for you to enter the customer information, a place for building information, and then you manually input the 5 baseline pressure values. And to kind of talk a little bit about the ResNet standard, you must do 5 baseline values. You need to have the program will calculate the average of that, but you also need to know what the range of the baseline is. And the average and the range contribute to the accuracy level. In short, the accuracy level is that if you have a baseline range of 5 or less, it will be standard accuracy. If you have a baseline range that goes from 5 to 10 pascals, then this will be considered a reduced accuracy. And then if the range is actually more than 10, it becomes an invalid test, and you will not be able to enter the results. Now, we do take the manually enter in the nominal baseline value and then the nominal flow for the what we see on our DG700, and then it will calculate what the real flow is based on altitude, temperatures, and the like. So you will have a value of the nominal test values down at the bottom on the next screen. And the iTech ResNet application does have the ability then to take the test results and email them. You can email them as you see on the screen here. You're also able to email them in a BLD file, which is the BLD extension allows the TECTITE program to read all of that information, and then you could do it as a more complete form, or if you don't want to type in all of the house information or building information, just do that in TECTITE and just read it from there. So some of the other tests using a blower door is, determining where the air leakage path may be. And you'll see in the lower left, this picture was taken without the blower door running using an infrared camera. This is an older picture. And then the picture on the right shows the air leakage that is taking place behind some kitchen cabinets on an interior wall. So a lot of times you will have, if there's enough connections in the interior of the house, you can have airflow show up on an interior wall, and that's why the house may be uncomfortable. Other tests are using, we want to do duct leakage diagnostics. So we use a pressure pan to determine if the ductwork is connected to the outside. This will not give you a CFM value. It's very much a qualitative value, qualitative test, and so it will help determine which registers might be connected to the outside if you want to continue doing some air sealing work. Duct leakage diagnostics, one way to do it is a blower door subtraction test, where we compare the test results of registered sealed and unsealed. So we do 2 blower door tests and subtract them and determine what sort of values there might be for duct leakage. And then certainly for duct leakage to outside, doing a simultaneous pressurization or depressurization of the house while running a duct blaster, and that's a much more accurate indication of duct leakage to the outside. We also can use a blower door to help with zone pressure testing and basically determining which area might be more connected to the house than another. So for example, the attic or a crawl space or a garage. So it can help identify where those dominant leaks would be, and we've developed a utility program called a zone pressure diagnostic utility, which helps runs you through the test and helps you determine what those pressure values mean and where they're at. Some other useful values, some other useful information is fan calibration. People will generally ask us about that. Fans maintain their calibration unless there's some sort of physical damage that might occur. So physical damage might be where the fan has been dropped on its face and the fan blades are now hitting the exit guard. Well, that means that it's in the wrong location. Certainly it's going to affect the speed of the fan, but we want to move that motor back into the right location. So we want to make sure that there's no leaks in the fan flow sensor, and we also want to make sure there's no damage to the housing or there's any broken blades. We can check the flow sensor for leaks by just taping off the holes, excuse me, and creating a vacuum with tubing and determining if there's a leak in that flow sensor. Sometimes if you have some very strange numbers, that will mean that there's some sort of leak either in the flow sensor or the tubing. So the flow sensor position, we can see that here with the motor. The values that we want to measure are right here, and this should be no more than 5/16 and no less than 3/16. Gauge calibration is recommended once a year, and that's full calibration is done at our facility. The cost of the calibration is $75 and is usually done in 3 or 4 days. You can do a calibration check. And so if you go to the blower door manual or the duct blaster manual and look in Appendix A, you'll see both how to check and correct the fan motor position, as well as how to perform a calibration check on in the field for gauges. The cost of upgrading an older DG700 to Cruise is $50 in addition to the $75. Now, some people that may want to have the USB port, unfortunately, we're not able to provide an upgrade on the USB port because we're changing too much of the internal configuration of the gauge, and so we can't upgrade from non-USB to USB. So for some more information, certainly we'd like you to go to our new website. We've just redesigned it to hopefully give you some more information and more easily navigable at energyconservatory.com. You'll also find on there articles on air sealing and duct leakage diagnostics, all of our previous newsletters. Certainly all of our product manuals and guides are online. We have added some video quick guides for both the blower door and the duct blaster. The blower door is quite recent, probably within the last about the last 2 months or 3 months. You'll also find those on YouTube, and we also have links to other sites. And this is also where you would download the latest version of software. So if you think you've got an out-of-date version, go to our website and just find that. So as we mentioned, our next webinar will probably be the end of October for early November, and it's going to be on ResNet testing. So watch for the next newsletter from the Energy Conservatory for more information. This recording will be available for download and viewing from our website sometime in the next 2 weeks. So that should be something you can look for. And now, if we do have a couple more minutes, and looking to see if there are any questions, and at present I don't see any coming in here, and there are some. So what do we? What kind of questions do we have? Okay, so there was some people have. One of the questions was the availability of a Wi-Fi adapter. We did show this at the ACI National Conference back in April. At that time, as a prototype, we are still working on it. We are hoping that we would have something available by the end of December, 1st of January. We're still working on it. It's a new area for us. We're trying to see what, get through all of the various problems of connecting through Wi-Fi. That would allow the ability of the being able to take readings with an iPad or an iPhone to have that on a display and make it a little bit easier to look at some things. Question on the duct blaster test to the outside. Need a little bit more specific information, but generally the duct blast, the procedure for doing a duct blaster test to the outside is running the blower door simultaneously with the duct blaster. And so the easiest thing to do is to pressurize the house, maintain 25 pascals, and then turn on the duct blaster to pressurize the ductwork. And then what we're actually trying to do is get the duct blaster to read 0. When we read 0, we've determined that there's as much airflow moving into the ductwork on the interior of the house as there is pressure from the blower door. And so how much air is needed to maintain that then gives us the equivalent of how much air is actually moving to the outside. We do have a schedule of webinars that we are working on, and one of them will be on advanced duct leakage testing, and we'll go more into the procedure and how to go through with duct leakage testing. We have a number of things that we'll be showing and talking about in the near future, so we hope that you can come back. We certainly invite your comments and questions. If you go to our website, and if there is a particular website or a webinar that you would like to see, or something that you would like us to address, please send us a note. Love to hear about it and see what we can do to provide that. If it's not something that's going to be coming up soon, then hopefully we'll be able to help you with that process over the next few weeks. But it's something that we want to be able to provide you with more useful and better information to make your life easier when you're doing blower door duct leakage or any type of building performance measurement, whether you're an energy auditor or a weatherization person or a home performance contractor. So with that, we're now closing in on 1 hour, and I want to thank everyone for participating and being here, and look forward to your questions on email. You can also send it to info@energyconservatory.com, and we'll try to address those as soon as we can. We will also send a note out when we have our next newsletter with the link for being able to view or download this presentation. So with that, thank you. It's been an hour. Thank you for being an attentive audience. We'd like to have you back again, and see you soon. Thanks.